we're going to look at how to factor an expression. And so our goal is to be able to use the greatest common factor of terms to help us do that. And if you remember, we talked about distributive property in lesson 4.4, and that was expanding expressions. And factoring expressions is kind of the opposite of that. So we're going to start with something that looks, if you look at the bottom here, that looks like this, and we're going to try to get to this over here. And so I say it's the opposite of distributive property because if you look the right side, this looks like something where I would use the distributive property. In fact, in lesson 4, we talked about how we expand expressions by taking this number that's out in front of the expression in the parentheses and multiply by each term inside. And so what we're doing is we're trying to figure out, well, what number goes outside here that I multiply each of the terms inside by. But again, all of this is equivalent expressions. We're trying to write equivalent expressions, so I can always double check my work after I factor an expression. Well, what if I do just use the distributive property? I should get back to where I started with, what I started with. And we see with this example here, well, what do I get when I take 3 times a? That's 3a. What do I get when I take 3 times 2y? Well, that's 6y. Now if I compare, they're the exact same. So it's an equivalent expression. Alright, so that's a lot of stuff right away, but what we're going to do is we're going to use 3 steps really. We're going to first look at our terms, and we're going to decide what's the greatest common factor. What's the biggest number that I can divide each term by? And then I'm going to actually do that division. So for this example here, I look at 3a and 6y, and I realize that I can divide both of these terms by 3. So that's my greatest common factor. So then step 2 is to actually do that division. So I take what's 3a divided by 3, and what's 6y divided by 3. And so I rewrite my terms after I do that division. So 3a divided by 3 is 1a, so that's where we write a there. 6y divided by 3 is 2y, so that's why you write that there. And then lastly, I put that in parentheses here, and then the number I just factored out, the number I just divided each term by, goes outside the parentheses. And then voila, we have our factored expression. Okay, so that was a lot. Let's go and look at see what this looks like on another example problem. So I gotta move some things around here. Okay. So here's my next example. We've got this problem here. I want to know what's the factored expression of this. So I'm trying to write an equivalent expression, and it's going to look something where I've got a set of parentheses and a number outside of it. So first step is what's the greatest common factor? So what's the biggest number that I can divide negative 2x by and negative 6? Well, I know one way to think of it is, or what are all of the factors of 2? Well, I can divide 2 by 1, and I can divide it by 2. There's no other numbers I can really divide it by. And what are the factors of 6? Well, I can divide 6 by 1, I can divide 6 by 2, I can divide 6 by 3, and I can divide 6 by 6. Right? Each of those give me a whole number when I do that. So now that this is one way to do it, is I can make a list of all the factors, all the numbers that I can divide my term by. And then I see, okay, well, what's the biggest number that they both have in common? Well, both can be divided by 2. So that means my greatest common factor is 2. So then, step 2 is I know that each can be divided by 2, so let's go ahead and do that. What's negative 2x divided by 2? Well, negative 2 divided by 2 is negative 1x, so I'm just going to write that as negative x. And then what's 6, or negative 6, divided by 2? That is negative 3. So here I have my terms. So what I'm going to do now is I'm going to write those inside the parentheses. So now I'm writing negative x minus 3. And then outside the parentheses is where I put my greatest common factor. Okay, so what I can do is I can check this. If I do this backwards and if I would now expand this expression, I should get back to where I started with. So here in red, I'm kind of doing a check. So 2 times the expression negative x minus 3. I'd use the distributive property to multiply 2 by both of the terms inside. So 2 times negative x is negative 2x. 2 times negative 3 is negative 6. How does this look compared to what I started with? And I can see that they're the same thing. So that means I've done my steps correctly, because this is an equivalent expression. It's just another way of writing our original expression. But we found the greatest common factor. We divided each term by the greatest common factor, and then I used parentheses and the greatest common factor outside of those parentheses to write my expression. Alright, let's look at one more again here. Let me see if I can change. Oh, well, let's go with green. I'll go brown. Alright, so factor the expression 14x plus 28 minus 6y. Similar thing, step 1. What's the greatest common factor? So let's think. So greatest common factor. What are the biggest numbers that I can divide, or what are the numbers I can divide 14 by? I can divide it by 1, I can divide it by 2, I can divide it by 7, and I can divide it by 14. What are all the numbers I can divide 28 by? Well, I can divide by 1, I can divide it by 2, I can divide it by 7, I can divide it by 14, and I can divide it by 28. And then 6. Well, 6 can be divided by, we saw this before, 1, it can be divided by 2, 3, and 6. Alright, so now I look and I examine this. Which of these are the biggest, or what's the greatest common factor is what I'm looking for. Excuse me, I'm just trying to adjust so I can get some different colors here. Alright, so my biggest factor that I can divide all of them by is actually coincidentally, once again, the number 2. So step 2 then is I'm going to go ahead and I'm going to divide each term by my greatest common factor. So 14x divided by 2 is 7x. 28 divided by 2 is 14. And negative 6y divided by 2 is negative 3y. So step 3 is to rewrite by putting the greatest common factor outside of that set of parentheses. So we've got, sorry, not 3, it was actually 2, right? We divided each term by 2. So now I'm just rewriting these. 7x plus 14 minus 3y. There's my factored expression. Again, if I double checked and I distributed this 2 back to each term, it's going to take me back to what I had at the start. Let's look at one last example, and this example is a little bit different because there's not only number that I can take out of each term, right? When we're factoring, we're figuring what's the biggest number I can divide each term by, but also what's different here is I've got a letter that's the same in both terms. So if we go step 1, my greatest common factor, we know that 12 can be divided by 1 and 2 and 3 and 4 and 6 and 12. 4 can be divided by 1 and 2 and 4. So what's my greatest common factor? Well, my greatest common factor is 4. Okay. Now, here's something to note. Whenever I have two terms that have the same variable, have at least one of the same letters, I can also take that letter out. So I'm actually going to say that my greatest common factor is actually 4x. So what I'm going to do is I'm going to take an x out of each term, which means it just goes away. So when I'm doing the division part, like we saw in step 2, I'm just going to worry about the numbers and not I'm not going to worry about the letter x, because I'm going to take that out of both terms. I'm factoring it out. I'm taking it away. So 12 divided by 4 is 3. 4xy divided by, sorry, not x, we said we're ignoring that. 4y divided by 4 is 1y, which is the same thing as y. Alright, so step 3 then is I'm rewriting this. I've got 3 and I've got y, because what I've done was, since they both have an x in them, I can take that out. So my greatest common factor is 4x, because I could divide 4 from each number, and I could also take an x out of each term. And so here is my factored expression. And one thing I did incorrectly in this is that this should actually have been, this should actually have been a negative 4y. So this was negative y. So this really here should be 4x times 3 minus y. Okay. So if we look at this other one here, I'm not going to go through this one completely, but check and see. Okay, what's the greatest common factor? Well, we could look, what's the biggest number that divides all of these? And that would be my greatest common factor. But also, since all of these have the letter A in them, I can also factor out the letter A. So at the end, I'm going to have a factored form, which in this case will be, I don't remember exactly. Maybe it's 2, this was 12, 10, 9. Yeah, so I'm going to divide each by 2, and you could go through the steps to do this, but I'm going to divide them by 2, but then I'm also taking out the A. So my factored form at the end is going to be 2A, because each term had an A that I could take out. Okay, so again, if we jump back here a ways, we had 3 steps. We find my greatest common factor. I divide each term by that greatest common factor. And then I write those new terms in parentheses and put the greatest common factor outside. Okay? And the last thing that we said was, if they all have the same letter in them, then I can also factor that out. So we said for this one here, I'm going to take out an A in addition to taking out a 2. All right, hope that helps.